Under the Whyte notation for the classification of steam locomotives, 2-1-0-2 represents the wheel arrangement of two leading wheels on one axle, usually in a leading truck, 10 powered and coupled driving wheels on 5 axles, and two trailing wheels on one axle, usually in a trailing truck. In the United States and elsewhere, the 2-1-0-2 is known as the Santa Fe type, after the Atchison, Topeka and Santa Fe Railway that first used the type in 1903. Other equivalent classifications are UIC classification 1E1, French classification 151, Turkish classification 57, Swiss classification 5/7, Russian classification 151. Overview. The 2-1-0-2 wheel arrangement evolved in the United States of America from the 2-1-0 decapod of the Atchison, Topeka and Santa Fe Railway. Their existing 2-1-0 locomotives, used as pushes up Raton Pass, encountered problems reversing back down the grade for the next assignment since they were unable to track around curves at speed in reverse and had to run very slowly to avoid derailing. Consequently, the ATSF added a trailing truck to the locomotives which allowed them to operate successfully in both directions. These first 2-1-0-2 locomotives became the forerunners to the entire 2-1-0-2 family. The trailing truck allows a larger, deeper firebox than that of a 2-1-0-0. Like all 10 coupled designs, the long rigid wheelbase of the driving wheels presented a problem on curves, requiring blind drivers, lateral motion devices and much play on the outer axles. To limit this problem, the driving wheels were generally small, up to 64 inches, which in turn generated the problem of insufficient counterweights to balance the weight of the driving rods. The 2-1-0-2's inherent problem was the low speed restriction on the type, which was about 35 miles per hour. Further, the 2-1-0-2 had other inherent restrictions. The massive cylinders that were required on locomotives in the United States for high tractive effort had the result that no reasonably sized valves could admit and exhaust steam at a sufficient rate to permit fast running. In addition, the 2-1-0-2, like the 2-6-2, had its main rod connected to the third axle, very near to the center of gravity, which created a violent nosing action when operating at speed. The peak of the 2-1-0-2 design limitations was reached in the United States in 1926, and was overcome with the advent of the superior 2-1-0-4 design. Usage. Locomotives with a 2-1-0-2 wheel arrangement were used in a number of countries around the world, including those in North America, Western Europe, China, the Soviet Union and Africa. Continental Europe saw a fair number of 2-1-0-2s, although the type was always less popular than 2-8-2 Mikados and 2-1-0 decapods. A large number of European 2-1-0-2s were tank locomotives, taking advantage of the symmetrical nature of the wheel arrangement. Argentina. The meter-gauge General Manuel Belgrano Railway in Argentina operated the E2 series of 2-1-0-2 locomotives. In 1956, Mitsubishi Heavy Industries of Japan constructed a batch of 10 2-1-0-2s based on this design for the isolated ramal ferro-industrial Rio Turbio, 750 mm gauge railway in the southern Patagonian desert to haul coal from Rio Turbio for shipping from Rio Gallegos, Santa Cruz. These required modification by Livio Dante Porta to achieve the full potential. 10 more powerful examples were introduced into service in 1964. Belgian Congo. 2 classes of 2-1-0-2 locomotives were used in the Belgian Congo. 2 locomotives were built by Douin Saint-Pierre for the CF du Congo Supérieur Grand Lacs Africans in 1937, numbered 60 and 61. They had 510 by 530 mm cylinders and 1060 mm diameter driving wheels, with a working order mass of 64.7 tons. One locomotive was built for the CF Dubar Congo Okatanga by Societe Anonyme John Cockerell in 1947, numbered 901 and later renumbered 802. It had 540 by 550 mm cylinders and 1,100 mm diameter driving wheels, with a working order mass of 94.1 tons, a great area of 4 square meters, an attractive effort at 65% boiler pressure of 14,215 kilograms force. Canada. In 1916, Canadian National Railways took delivery of 10 Class D102-102s from an order made by the short-lived Canadian Government Railways and built by AGA. 10 more were delivered from the Montreal Locomotive Works in 1918, and another 25 slightly modified T1Cs in 1920 that were 1,100 pounds lighter. Canadian Locomotive Company produced 5 T2As in 1924. 10 ALCOs named T3As were acquired from the Boston and Albany Railroad in 1928. Canadian Locomotive Company produced the last series of 2 102s for CNR, a batch of 15 T4As in 1929, and 18 T4Bs in 1930. The 2 102s began to be scrapped in the mid-1950s, with the last models being used until 1961. There are 2 surviving CNR 2-102 locomotives. One is number 4008 on display at the CNR station in Rainy River, and the other is number 4100 on display at the Canadian Railway Museum in Delsin, UC. China. The mainstay of Chinese steam was the 2-102 locomotives. This was the wheel arrangement of the Chinese QJ-class locomotives that were based on the Soviet LV class. They were built until 1988 and were still in widespread service until the final steam runs in 2003. After retirement, some of these QJ-class 2-102 steam locomotives found the way to the United States of America, where they are used in excursion service. In 2006, Multipower International restored 2 Chinese QJ-class locomotives to Federal Railroad Administration Part 230 specifications and delivered them to Railroad Development Corporation, Germany. Examples on the German railway systems included classes BR-84 and BR-85, both standard designs built in 1935 and 1937 respectively, and Class BR-95, built in 1922 by the Prussian State Railways. From 1936, the German railways built 28 3-cylinder 2-102 tender freight locomotives of Class BR-45, which were the largest steam locomotives on the system. Mozambique. While the 2-102 wheel arrangement was not very common in Africa, the Lorenzo Marques system in Mozambique had altogether 37 locomotives of this type in 3 classes. 9 locomotives of the Series 200, numbered 201 to 209, were built by Baldwin Locomotive Works between 1915 and 1919. 6 more Santa Fe type locomotives of the Series 214, numbered 214 to 219, were built by Henschel and Son in 1951. 22 locomotives of the Series 250, numbered 251 to 272, were built by Henschel in 1955. Romania designed its 151.2 L-V-000 class as freight locomotives, in order to serve the Kyle freight remain. These locomotives used a straightforward two-cylinder 650 by 720 mm engine with 1,500 mm diameter driving wheels and a total weight in working order of 123 tons. The heating surface of the boiler was 254.8 square meters, of which 98.5 square meters were superheated, while the grate area was 4.72 square meters. At 21,294 kilograms force tractive effort, they were the most powerful steam locomotives built in Romania. Two of these locomotives were built by the Malaxa Works in 1939 and 1941, numbered 151.001 and 151.002. Number 151.002 was preserved. South Africa. On 3 feet 6 in, this wheel arrangement was first used by the South African Railways in 1927. Two Class 18 steam locomotives, the most powerful non-articulated locomotives to see service on the SAR, were introduced on the line between Witbank and Germiston in an attempt to ease problems that were being experienced with increasingly heavy coal trains. It was designed by Colonel F.I. Collins, chief mechanical engineer of the SAR from 1922 to 1929, and built by Henschel and Son in Germany. They were three-cylinder locomotives, with the two outer cylinders using Walsh-Urts valve gear and the inner cylinder using Gressley conjugated valve gear that was actuated by the motions of the outer cylinders. One more 102 locomotive, the Class 20, was designed by A. G. Watson, chief mechanical engineer from 1929 to 1936. Only one locomotive was built by the SAR at its Pretoria mechanical shops at Salvakop in 1935. In 1950 this sole Class 20 locomotive was modified to an experimental condensing locomotive, equipped with a condensing tender that was ordered from Henschel in Germany in 1948. Beginning in 1951, tests with the condensing Class 20 were conducted in the Eastern Transvaal and the Karoo. The positive results of the condensing trials proved the viability of condensing locomotives in South Africa and led to the introduction of the Class 25484 condensing locomotive fleet in 1953. Soviet Union. In the Soviet Union, two 102 type locomotives were used to haul heavy freight trains. Two series were relatively common, the FD with more than 3,000 built through the 1930s, and the LV. The FD class was developed from Alco and Baldwin heavy freight locomotives that were imported to Soviet Russia, where they were designated as the TAR and TB classes respectively. The first FD-class locomotive was built at the Lugansk Locomotive Factory in 1931. In 1932 the Voroshilovgradskom plant started with the mass production of 20 locomotives. In the process of production their construction was improved constantly. At the outbreak of the Great Patriotic War in 1941 production was interrupted, and was only resumed in 1942 when 4 locomotives were built in Ulan-Ude. The total production was 2,927 locomotives of 20, and 286 locomotives of 21. The two subclasses only differed in the type of superheater. In 1958 1,054 FD-class locomotives were sold to China, where they worked until the 1980s. A much lesser number were sold to North Korea at around the same time. The Russian locomotive Class 55 was developed from the previous L-Class 210 locomotive by the Voroshilovgrad factory. It used a feed water heater to increase thermal efficiency, and it was the most efficient freight steam locomotive in the Soviet Union. with thermal efficiency of 9.3%. The first prototype was named OR 1801. A total of 522 LV-class locomotives were built. Several were preserved, including the first OR 1801 and the last LV 0522. In Spain, the 2-1-0 arrangement was represented by one series of 22 locomotives. They were initially ordered for the Compañía del Norte, but the Renfe kept the entire series in reserve. Built between 1941 and 1944 in the La Maquinista Terrestre y Maritima factory in Barcelona for hauling heavy coal trains, they were amongst the most powerful steam locomotives in Europe. They had 3 cylinders, but used simple expansion and were known as Santa Fe locomotives. United States of America. In the United States, the 2-1-0-2 type was produced between 1903 and 1930. The first were the Santa Fe engines of the 900 and 1600 series, which were an early type with few advantages over the 2-1-0 decapod type save their ability to operate in reverse without derailing. By 1919 the road was building the definitive type with the trailing truck supporting a large firebox. These were of the 3800 class, and one was equipped with an experimental 2-axle trailing truck to become the first 2-1-0-4 Texas type. About 2,200 Santa Fe types were built, including about 500 of the 2 United States Railroad Administration World War I standard designs. The Santa Fe had the most, 352 total. There were 2 USRA standard 2-1-0-2s, the heavy and the light. The heaviest 2-1-0-2s were 10 built by Baldwin Locomotive Works for the Reading Railway circa 1931, weighing 451,000 pounds, engine only. At 104,000 pounds force, the Illinois Central Railroad's 2,800 class rebuilds probably had the highest calculated tractive effort of any 2-cylinder steam locomotive, though the weight on drivers was only 333,000 pounds. The Baltimore and Ohio Railroad ordered its first 2-1-0-2 from Baldwin in 1914. From 1914 to 1956 the 2-1-0-2s bore numbers commencing with 6, hence the nickname Big Sixes. Designated the S-class, there were several subclasses. They began to be withdrawn in 1951 and were all scrapped by 1959.